Hi guys, Buildzoid here, and it's the obligatory Z490 launch day video. So basically I decided for this video, I'm not going to show you any well, we're going to run some overclocked Cinebench, but basically the thing that has me excited about Z490 is just how very easy to overclock this platform is. Yeah, most of my testing has been focused on what's the memory overclocking like, what's the CPU power consumption like, because the overclocking is basically coffee like again. Um, uh, what are the thermals like? So how much power can you cool? How much power can you push into the CPU before you run out of cooling? How far can you push the memory? That kind of thing. And well, if you read through my profiles here, you might notice one that looks extra special. Anyway, let's get into the BIOS. And we're just going to start with a nice basic power consumption demonstration here in Cinebench, because what I really this was one of the first things I tested was just so how much power can we cram into one of these 10900Ks before they become completely uncoolable? Turns out a ton of power, and I'm just using so the setup here. I should have introduced the setup before getting into the overclocking. So the setup here is of course the MSI Z490 Unify ATX board. Thank you to MSI for the board, and then also a 10900K that I have on loan from MSI as well. So thank you for the CPU as well. The right now we're gonna run just the 2 sticks of my this stuff there. Patriot Viper Steels, 4400 megahertz CL19. So, yeah, 2 sticks of that. We're also going to run 4 sticks of that, and you might be like, but Buildzoid, isn't this a daisy chain motherboard? Yes, but it's a 6-layer tabbed trace daisy chain motherboard, and there is a major difference between this and your average daisy chain. And anyway, so actually that's a bit low. For Cinebench, we can go really fast. We don't need to change anything there. I was thinking I'd go through the BIOS while talking about other things. Apparently, I can't multitask that much. That is literally too hard for me. The cooling system is a 280 millimeter EVGA CLC 280. I already said that. Yeah, see, I'm repeating myself. I literally can't multitask that hard. I have not yet checked which LLC is optimal, but mode 4 on a lot of MSI motherboards is okay, and this is just Cinebench. It's not exactly, heavy transient loading that we're looking at here. So maxing out the switching frequency causes the VRM to crash. So that's just something I noticed, so we're not going to do that. Anyway, yeah, so the EVGA 280mm AIO, maxed out fan speed on that, so 2000 RPM. Yeah, that's the cooling system. It's definitely not, for the thermal paste, I'm just using Kingpin Cooling KPX. So basically, this is not what I would consider like a truly extreme water cooling setup. Like, not a hardcore water cooling setup for the CPU here by any means. If I was doing like a proper build with a 10900K, I'd probably be going for like a 360 or a 480 millimeter radiator dedicated just to the CPU. Liquid metal on the IHS, which I can't use with this CPU because it's on loan and I need to return it with a legible IHS, and obviously liquid metal kind of tends to destroy IHS inscriptions. Yeah, but if I was building a system with this, liquid metal, massive radiator, just full custom loop, best water block you can get your hands on, or more like you can afford, because right now there's like some water blocks that are going for like $200+. And I think this is all I want to do for this sort of like baseline power consumption test in Cinebench. So the current clamp hooked up, and we'll be looking at the temperatures and we'll be looking at the power consumption. So, yeah, also the capture card is being derpy. So, there. And it's gone again. Man, this freaking capture card. Ah, there we go. Now it's working. So we're just going to blow this up because ultimately, like, you don't need to see the whole screen. You just need to see the like temperatures and Cinebench. So I have an old version of Core Temp here, so the temperature readings aren't exactly the world's well, the temperature readings are correct. It's just that it doesn't know what CPU it's looking at. And then here we have Cinebench R20. So this is 5.2 gigahertz with like we're idling at 1.42 volts, but we're not going to be getting 1.42 volts at full load. This is not die sense voltage at all, right? Like, and I unfortunately don't have a way of getting a dice. Well, actually, let me try something. Let me quickly try something. Okay, so I just realized that the ground system. Oh, actually, you're not going to see that, but basically, I'm just moving one of the sort of like I have these double-ended female standoffs. So yeah, like I use those for like getting the ground probe in. So go. It's our ground. And so right now, let's try to get that. Can I get that in the shot? I can't. There. Totally a good way of doing things. So if the voltage drops, then like this is probably relatively accurate. If the voltage goes up, then obviously this is not die sense. And that's socket. That has to be back of socket. Yeah, so the CPU is probably getting like 100 millivolts less than that. Anyway, as you can clearly see, the CPU is also pulling about 30 amps right now. And the temperatures are, I mean, they're 90s, but this is 360. Actually, now it's more like 370 watts going into the V-Core VRM. So even assuming a VRM efficiency of like 90%, which is low for the VRM on this motherboard, that would be 330 watts making it into the CPU. But with the actual efficiency of this VRM, we're probably looking at more like 340, 350 watts of power going into the CPU, and yet the chip is still staying under 97 degrees on a 280 millimeter AIO. Admittedly, you know, I'm not running this up to the saturation temperature of the water here, mostly because, and I think I just screwed something up. The multimeter probably pressed the power button because it was sitting on top of it. Good job, me. But anyway, yeah, the point is, and the capture card's being stupid again. Like the point is that like if you were running this much power into a 9900K, it would be completely uncoolable with a 280 millimeter AIO, saturated or otherwise. So Intel, and the reason for this is with the 10900K, with the 10700K, and the 10600K, instead of having a 0.8 millimeter die, you have a 0.8 millimeter die thickness. You have a 0.5 millimeter die. So essentially, Intel has really polished the thermal performance of the 10 series K chips, and it shows. Like these things are so much easier to cool. We'll just do a quick pass again. This time the water is quite a bit warmed up in the AIO, of course, so it's not going to be as cool this time around, but yeah. Like, the thing is, if you had a bigger, better cooling system, you could definitely cool this amount of power. Like, I have zero doubts about this being doable. It's just like, I'm on a 280 AIO. Like, AIOs have low liquid flow rates, so the temperature, like, the temperature, the problem with low liquid flow rates is that essentially you have hot water sitting in the water block, right? Like that's the main issue. Like if you have a big enough cooling system, the goal is that the water coming into your water, like you want, like the point of your radiator is to get the water temperature as close to the room temperature as possible. The point of your water block is to and then like the point of your pump is to take as much of that cold water and shove it as quickly as possible through the water block, right? And then the water block wants to have as much wants to provide as much surface area in contact to the water as possible, and that's essentially like the basics of water cooling right there. Um, the thing is, of course, with an AIO, you have a low pump flow rate, you have a low flow rate and small radiator, and that radiator is made of aluminum. And like, I know a lot of people might be like a 280 radiator. It's a small radiator. It's also made of aluminum, and copper radiators do actually have a. It's not a huge advantage, but it's a noticeable advantage compared compared to aluminum radiators. And the other thing is like if you look at custom, like the AIO radiators are like 25 millimeters thick. If you look at custom loop radiators, the high end ones are like 60 millimeters thick. So yeah, like this is not, in my opinion, a good way of cooling a 10900K. But even then, it's not actually running that hot. I know a lot of people might be like, but it's at 90 degrees. This is 360 watts. If you shove 300 in or like, well, not 360 watts, but this is like 340 watts going into the CPU. If you shove 340 watts into a 9900K, it's gonna, like, you can't. Like, you're gonna run out of cooling no matter what you do. So, yeah, I'm really, really impressed with how relatively easy these chips are to cool, considering that they pull so much freaking power. So, that's one thing about Z490 that I really like. And of course, we're looking at a 10900K here. If you had a 10700K or a 10600K on a 10700K, you have 20% less heat output. Just because you have two less cores, you have 20% less heat output. Like, it's going to be a lot easier to cool one of those than it is to cool a 10900K. So like a 10700K to a 9900K, that's not a contest. The 10700K is vastly superior. But there are other improvements with the 10th generation, namely in the memory overclocking department. Normally, like, this would be a bad idea. On an ATX Z390 motherboard, 4600 megahertz, not really a thing that you can do. But here it is a thing. It is very much a thing. We just need to bump up the system agent voltage quite a bit. And that should work. And you can even go higher than this with other memory chips. BDI is relatively heavy on the memory controller, or you can just mash more system agent voltage into it. The memory controller scales quite well with system agent voltage. I'm just not really brave enough to. Well, actually, I do have a set of settings that are at like 1.6 volts that we're gonna see. So yeah, that right there, absolutely, like that's as smooth a memory overclocking experience as you're gonna get, as far as I'm concerned. Like, it does not get better than that. Now, right now, the sub timings aren't optimized; they're all auto, but we're still gonna get a decent amount of memory read bandwidth out of it. And this is relative. Like, this would be, if I wanted to, we could get this stable. Actually, this right now might be stable just because the timings are so very loose. Yeah, 62 gigs, this is not the fastest, like, largest amount of bandwidth I've tested. I've had I have memory settings that have gone up to, like, 67 gigabytes per second. But this is, all auto settings, and it's just, like, it's amazing that this even posts. This is a 4-DIMM motherboard. If you're on Z390, you have ITX boards where going over 4400 megahertz is incredibly difficult. You have ITX boards where 4600 megahertz is that's it. You don't really get past that. On ATX Z390 boards, most of them you're going to be lucky to get 4266 working on 2 memory sticks, because a lot of them are T topology, and a lot of them are just generally kind of bad. And then even if you go with even on the T topology boards, if you go up to 4 DIMMs, at best you're going to max out at 4400, but then the 9900K's memory controller kind of can't take it anymore. So yeah, you end up with like the memory overclocking on Z490 compared to Z390 is just so much better. Um, so that's another reason I really like this platform, and I'd actually like to show you some rather impressive screenshots, and I'll actually demonstrate some of this running right here, right now. Um, but yeah, I've taken a few. I think this is the. Oh no, this one's okay. This is one of them as well. So this is 32 gigs running 4240. Yeah, this is 32 gigs running 4240, CL16, and passing passing HyperPi. Not a full stress test, right? This is very much HyperPi is not a full stress test, but um, it's a lot heavier than something like Geekbench 3, right? So there, that's on the Unify 4-dim board running. Like this is the kind of overclock that you would be, sort of attempt like this is where most of the Z390T topology boards would top out for a 4-dim overclock for like 32 gigs. And here it's like it's a daisy chain and it does it. Like holy hell. Right? Like oh my god, this is amazing. So that's a kind of more casual overclock right there. Do we have anything more aggressive? Oh, here we have a 4444 at 17, 18, 18, right? So this is 2 by 8. And again, HyperPi stable, 8,400 Geekbench score at like on settings that this you could run this daily. In fact, this memory kit that I'm using for this screenshot, I've had settings that are 4400, 17, 17, 17 fully stable on it. So, like, Z490, and this is an ATX board, like, because on Z390, all of the impressive memory overclocking I've done, that is actually, like, high speed, low timings, all of that was done on, like, ITX boards and, like, extreme overclocking boards like the Gene, like the Dark, like 2-dimmers, essentially, not 4-dim motherboards with daisy chains or T topologies, because they're, like, 4 dims is bad for memory overclocking, but Z491, like, part of it's the motherboards. The motherboards are much better at memory overclocking than ever before. And part of it's also just, like, the memory controller's better than ever before as well. And so here, we're probably, like, we're not actually going to run these. Well, we're going to load these settings up. I don't think they're going to actually run. So this is this is 32 gigs. Like, again, daisy chain board, but running 4280 megahertz, 13 CL 13, 12, 12, 28, 220. We're going to actually run this right here, right now, because that is just an absolutely ridiculous memory overclock. And the performance is there. Well, the latency isn't there for whatever reason. Like, I've had no luck with getting the latency on this board very low. My theory on that is that basically, like, at least not at high frequencies. Maybe at low frequencies it gets better. At high frequencies, the board runs extremely loose RTLs and IOLs, and the end result of that is it just has piles and piles of latency. But the bandwidth is amazing. Geekbench 3, if you're, like, competitive in, like, good memory overclockers for Geekbench 3, the goal is to hit 10,000 memory score for the multi-core the multi-core memory subtest. You want to hit like 10,000 or higher. If you can do that, you've got some very good memory settings. This is not 10,000, this is 9,800, but it's very close, right? And this is on a 4-dim board running 32 gigs of RAM. So this is not like this is on a 4-dim daisy chain running 32 gigs of RAM. Like, this is like it's insane. Because this is also like this is because the 10,000 sort of target for Geekbench 3, you're again looking at 2-dimmers, ITX boards, and ATX extreme overclocking boards like the Apex, like the Dark. You're not looking at boards like this where it's like this is like MSI's left a lot of extreme overclocking features present on this motherboard. Like, it has an LN2 mode. There's a fail set jumper, but at the end of the day, it's got 4 DIMMs and only 6 PCB layers. This is not what you would choose as your like memory overclock. Like, this shouldn't be doing this well in memory. If this was a Z390 board, we'd be looking at like maybe a little over 9,000, not almost 10K. So Yeah, Z490 is just absolutely amazing when it comes to memory overclocking. Oh, and here's like a more casual version of the same thing where it's at 42, 40, 14, 15, 15. And I think this was at like 1.6 or 1. I don't know, this was 1.7 volts, if I'm not mistaken. So, yeah, the memory overclocking is just so very strong. So, and also it's very strong even on dual rank DIMMs. So we're gonna do a quick. So right now we're at 4600 CL1921. I'm also gonna do a quick overclock with these right here. These are my 16 gig Corsair Dominator DIMMs. So we're going to run 32 gigs on dual rank DIMMs, and we're also going to run 4 single rank DIMMs. Now, MSI actually says that this board is better with 4 single rank DIMMs than with 2 dual rank DIMMs, and well, my experience basically seems to match that. So yeah, I'm not sure how they're managing to do that on a day like daisy chains should generally favor 16 gig DIMMs over 8 like 2 by 16 should be better than 4 by 8 on a daisy chain if you're running the same number of ranks, because you can technically now get 16 gig single rank DIMMs, but you know, let's just pretend those are kind of rare, so you can kind of pretend they don't exist. Anyway, let's power this down, swap memory sticks, and we're gonna go for with these, we can go up to like 4133 quite comfortably. I've also done 4266 on them, but it's far more difficult. And so I'm not going to show 4266 right here, right now. So the board actually will auto-detect that I swapped the memory, which is why I don't need to clear the BIOS. It's just like a cool little feature of MSI boards. So this kit right here is rated for 3466 CL16. It is still Samsung B die. So it's not like it's on bad memory chips or anything, but it's not exactly. Actually, you know what? We're very loose right now. We're at relatively. Oh no, this is still on auto voltage. Yeah, so that was auto 4600. Admittedly, the kit I was using defaults to 1.45 volts because the XMP on that kit is 1.45 volts, but still, we're gonna set the VCCS. Actually, let's set both of those to auto. Like the board is very voltage happy. If you leave those two on auto, the upside of that is it makes it really easy to figure out if certain settings are even remotely possible. Okay, they're not. I guess they must have changed something with the BIOS versions, because on an earlier BIOS version, I was doing 4266 with these DIMMs. So apparently they changed that, but the board still recovers amazingly well from bad overclocks. So yeah, but that's not really like a general Z490 feature. That's just a feature of this board. But I'd assume it's going to be well. I've not yet had a chance to play with all of the other well, I have Gigabyte boards, so I will be playing with those. But I don't have any Asus or ASRock boards, so I don't know how smooth the overclocking experience on those will be. Anyway, so let's go for 4133, and in that case, we don't need to run 1921. That's very ugly to look at. So we're gonna go with something a bit more aggressive, like 171919, and we're gonna go back down to 1 point. And this is probably excessive, but whatever. Demonstration purposes. So the 32 gig crazy memory profile I have, that actually requires maxmem. So we're going to let this go all the way to Windows. I'm going to set maxmem, which restricts how much memory is available to the operating system. And it's a necessary setting for stability at high voltages with Samsung B die. And it can also help with stability on other memory chips as well. Man, imagine if the capture card would work. Make life so much easier. Normally it works. Like, I think it's just this GPU that it has a problem with right now. I put my memory sticks on the mouse cable, which is actually kind of annoying. So we're going to go 6000. Apply. Okay. And restart. So anyway, like 4133, like the thing is, these DIMMs, these DIMMs right here that just booted 4133 CL17, these normally have a hell of a time going over 3733 on Z390 motherboards. So again, it's just like Z490 is freaking great at memory overclocking. Though I think part of this is also we're using an MSI board. I'll need to try these on some like gigabyte boards, and then other motherboards from other vendors, because on Z390 the one board that actually played well with these memory sticks was an MSI motherboard. So it might just be like MSI has some specific optimizations for these memory sticks that the other Z390 boards were lacking. But even then, like the Z390 ITX board that was doing well with the Z390 board that was doing well with these was ITX, right? Whereas this is an ATX board, and we're doing like 4133 no problem. Anyway, let's go for the insanity profile. So I'll swap to the Patriots again. And yeah, we're gonna do 42. Well, probably not 4280. Well, we'll see. Like the board's been really good about posting absolutely ridiculous settings, so there's no reason not to try go for the full-blown insanity profile. And that was the multimeter turning off. And here we go. Now, the profile that I'm about to load up is very much not safe for long-term use. Like, the bigger issue with it is just, like, you can't even access all of the memory while running it. Like, that's probably the biggest issue with it. Anyway, hopefully it works. Okay, that loaded up. And here it is. So 52, 51, 4266 memory. 1.65 volts system agent. 1.5 volts IO. 1.94 volts memory. And the timings are as low as they go. So still 2-tick command rate. If you're running 32, like if you're running dual rank, I've not seen a 1-tick command rate dual rank setup on any I've not run that on any Intel platform. At least not at frequencies this high. So yeah, if you want to go fast, you kind of just give up on 1T command rate. And like the performance penalty from that, in my experience, really isn't that big. Like I see a lot of people focusing super hard on having 1T command rate, but like everything I've tested is just like, if you can do like 300 megahertz more, it's irrelevant. So yeah. Anyway, secondaries basically as low as they go. The TCWL for whatever reason doesn't want to go as low as it should, as far as far as I'm concerned. Like normally with a TCL of 13, I'd expect TCWL to do like 12, like 13, 12, 11, maybe even 10 or 9. And like basically anywhere between 13 and 9 should be a viable TCWL value, but this board for whatever reason has a really hard time with low TCWL, so that's at 16. I'd assume I'm guessing I might, like, there might end up being a BIOS update that actually fixes that behavior, where you don't need to run really loose TCWL. And yeah, because the board is so great at recovering, I've also tightened up all of the tertiaries, except these two, because these have a rather complicated relationship with some other timings, and so I just let the board deal with them. Anyway, yeah, and this is, this is 4266. at CL13. Like, this is hard to run. And I just realized I don't remember if I had hyperthreading enabled or not on this profile. I don't think so. Because the thing is, Geekbench memory score does not really scale with hyperthreading. So I'm just going to check. Okay, hyperthreading is disabled. We can re-enable that. It's like the thing is, I like Geekbench is just annoying to deal with. Well, I'm more like I was just testing if like disabling the hyperthreading wouldn't give me a slight edge in terms of stable like max settings, and it didn't. It really didn't help at all. So anyway, so now we're in, and admittedly we only have access to a lovely 4.3 gigs of memory. But we are in on 32, like, it's not really 32 gigs, but dual rank. That's the main point. Like, dual rank helps with the performance. So we're dual rank 4266 CL13 on a daisy chain motherboard. Like, that's absolutely insane. If we look at the read bandwidth right now, it should be actually, like, way up there. That's assuming it doesn't crash. It hasn't. Unfortunately, moving the mouse while IDA's running lowers scores. So, oh, looks like my phone ran out of battery. Okay, well, we'll just use the computer calculator. So, 4266 on a dual channel system should be transferring, how much is it? 16? Yeah, so basically 4266 should have a maximum memory bandwidth of 68.25 gigabytes per second. This right here is doing 67.4 gigabytes per second. Like, this is as efficient as you can basically be. Like, there's no bandwidth left on the table. Because that's the thing, is like a lot of the timings are essentially just getting you closer and closer to the maximum theoretical throughput. Write speed isn't quite up there. That's probably due to the cast write latency, which I don't know why it doesn't go higher. It should. I mean, go lower. Yeah, and unfortunately the latency is kind of terrible, and that's just like I noticed the same thing on Z490 I mean Z390 ATX boards, where it's like if I used memory settings that were really good on like an ITX Z390 board that were doing like 35 nanoseconds latency, if I used those exact same settings on an ATX board, there's like 5 nanoseconds more latency. So I just kind of came to the conclusion it's probably down to the extra just the like I assume it's just down to the trace length at that point, because I have no idea what else would be causing that. Because I could like if set the same exact primary, secondary, tertiary timings, and the main difference is like the 4DIMM boards just don't do low RTL timings as the ITX boards. So yeah, that's and that, like, as far as I'm aware, the RTLs are entirely dependent on just the motherboard itself, like physical aspects of the motherboard. So basically trace length. But yeah, like this is still ridiculous. Like it's ridiculous that you can run these kinds of settings on an ATX board. And the thing is, what's even more insane is like, so this, the Unify here, this is a $300 board. But MSI is using this exact same DDR like memory topology all the way down to like their cheapest Z490 boards. There might be some changes in terms of like memory power delivery, but essentially you should be able... Oh, now I remember why I had hyperthreading disabled. Small FFTs. Yep, it crashed, the CPU crashed. Oh well. If we run it at 5.1 gigahertz, it'll work. Yeah, but actually the cache crashed. Yeah, so that's annoying. Yeah, but essentially, like, you could get like a $200 Z490 board, and you should still have this level of memory overclocking capabilities. Whereas a 200 Z390 board, a lot of them kind of suck. Or actually, you can go even below $200 on Z490 and still, expect to get memory overclocking capabilities so like similar to what I'm showing here. Which just like that's insane. And also, I didn't want to change that. What we need to do is lower the cache. Probably lower the core speed as well. No, the core should be fine. What voltage is this at? This is at megavolts. Okay, that's probably not like. The thing is, the chips are temperature sensitive, so that's definitely not helping. But let's do that. Like, I'm gonna do a Geekbench pass. It doesn't even run that long. The CPU is so freaking powerful. Oh yeah, capture card. Yeah, I'm just making sure that the multimeter, like the current clamp doesn't go to sleep. So actually, you could watch the current draw. Let's pull up temperatures as well while Geekbench is running. So core temp, Geekbench 3. Because, yeah, Z490, like, if you like overclocking, this is awesome. Like, this is a great platform for overclocking. It's not the most cost-effective platform. I don't think the 10900K makes a lot of sense for the vast majority of people. But if you're into overclocking, I mean, this is essentially, like, the 10900K is capable of competing with X299 in a lot of multi-core benchmarks. But it's also way faster in single-threaded stuff. And so it's just like all around, like this as a benchmarking platform, this is just so much more flexible than X299. It's cheaper than X299. It's cheaper than a 3950X because a 3950X actually is also very competitive with X299. Threadripper isn't. For benchmarking, Threadripper, like, depends on what you're benchmarking. If you like benchmarking Cinebench, then sure, you can have a Threadripper. If you like benchmarking anything that isn't Cinebench, Threadripper is not good for like GPU scores or single-threaded stuff or really anything that's not like a mega multi-threaded benchmark. You don't want a Threadripper for that. And so there the choices are like mainstream Ryzen, like 3950X. So basically, for competitive benchmarking, it's like 3950X, 10900K, X299. Those are sort of like a similar category of CPUs in terms of what their capabilities, but the 10900K is cheaper than a lot of them. It's better at memory than X29, like it's way better at memory than X299. It's faster single threaded than a 3950X. Like it's not the best at any one thing. There are definitely workloads where X299 still will have an advantage, but yeah, if I was building like just a pure benchmarking system right now, and it was like I wasn't able to like, because here's the thing is like if I want to bench 3D Mark Vantage multi GPU, I'll pull out the X299 system, or I'll pull out a 3950X because a 9900K is just depending on what GPUs you're running, the 9900K isn't necessary, and you just want as much CPU score as possible, and so you need a lot of cores. But here, it's like, we have a lot of cores. We also have a ton of single-threaded performance available if you just disable cores, right? Like, you don't need the 10 cores, you can just disable them. You can disable hyper-threading per core. Like, I love this platform. Also, Geekbench managed to hit 99 degrees, yeah. I assume the current draw was quite ridiculous at some point. So, yeah. And also that's a 9,800 right there for Geekbench performance. Like, I love Z490. It's not like I'd say as a gaming platform, I don't think it makes necessarily a ton of sense. Like the 10600K, 10700K, definitely very solid gaming CPUs, but the 10900K I feel like this is an overclocker CPU because it can pull a ton of power and it's just like it's a memory overclocking beast, it's a single threaded beast, it's a, you know, medium rate, like for lower thread, like for sort like up to three. Like the thing is, like when I say 3D Mark, like you have to understand 3D Mark Vantage literally doesn't support more than 16 threads. If you run it on a CPU with more than 16 threads, it goes slower. 3D Mark Firestrike, if you run it on a CPU with more than 32 threads, it goes slower. If you run 3D Mark Time Spy, I think Time Spy only goes up to 16 threads. Time Spy Extreme goes up to like a ridiculous number of threads, but Time Spy, regular Time Spy, is 16. Um, if you run like 3D Mark 11, if I'm not mistaken, is up to 32 threads. It doesn't go past that. So also, like, these are all places where a 10900K is very capable because it fits within the thread limit of the benchmark, and yet it has way more single, like, per core, it is faster than everything else you can get, assuming you can get enough cooling for it. So yeah, I love Z490 as an overclocker. I wouldn't build, like, I don't know what you would build with as like a 10900K daily system. Like, it doesn't make sense to me. If you're a gamer, then just get a 10700K. And well, if you're building a workstation where you need a lot of cores, get a 3950X, get a 3900X, get literally anything other than a 10900K, because this doesn't have that many cores. But for like the weird sort of, you know, competitive benchmark, like the weird requirements of the competitive benchmarking scene, this is so freaking awesome, as far as I'm concerned. So yeah, and then I guess like the thing is, like, there's no real downside to the CPU over a 10700K, and also if you look at it from just a cores per dollar perspective, 10700K, 8 cores, roughly $400. It's currently a bit over that because, you know, quite high demand, launch day hype, but the 10700K should be $400 eventually. Same goes for the 10900K. It should go for $500 eventually. So if you're patient, you know, then that's something to look, you know, it could make more sense in the future. At the same time, you know, if you're patient enough, there is an argument to be made to just wait for Zen 3 and maybe then decide. But I don't know. Like, I'm not going to make that decision for you. Make your own decision there. Like, I'm not going to try predict the future on if Zen 3 is going to be like massively better than Z490. But yeah, like, as an overclocker, I freaking love this. This is just so cool. Let's try run Cinebench. I think it'll get really upset with me when I run it. As in, I think it'll get really hot right now, but we'll see. The memory, like the crazy memory settings, might actually help bump up the score a bit, assuming it doesn't overheat or crash. Cinebench is actually lighter on memory than Geekbench is, so this should be less of a problem to run than Geekbench was, but it does get hotter. Well, it can get hotter. Like, the thing is, Geekbench has there's a very nasty load spike in Geekbench, but it's very short, whereas Cinebench Cinebench R20 especially is a relatively long-lasting benchmark, and so yeah, it can, you know, like, this really can heat up the cooling system. Yeah, I think this is not going to work out. If it hits 100 degrees, it starts throttling. And yeah, so that's going to suck. Because it hit 100. Yeah. I need to, like, if the room was a couple degrees cooler, that would have worked out. But the room is pretty warm, and the CPU isn't helping matters. Yeah, well, it's still apparently still 25 degrees, but anyway. Yeah, so I like Z490. You know, and yeah. It's a really cool platform for overclocking. And I don't know, like, the thing is, so I guess, so overclocking wise, what are the considerations? Well, the CPU can pull a stupid amount of power. The CPU can get can produce a lot of, like, because it can pull so much power, it obviously produces a ton of heat. So in terms of cooling systems, yeah, if you want to max a 10900K, you're probably going to be looking at a 360 millimeter radiator or bigger. I would strongly recommend a custom loop. AIOs generally just, like, the thing is, AIOs just like a 360 radiator on an AIO is nowhere near a 360 on a custom loop. Assuming you're not buying one of those slim custom loop radiators, because those honestly kind of like if you're buying a slim custom loop radiator, it's like, why are you even building a custom loop at that point, in my opinion? Like, you should get the biggest blood. Like, the whole point of a custom loop is you can get massive rads. So yeah, get a bigger rad. And for the 10700K though, you know, something like an AIO should actually be pretty okay. A 10600K, an AIO should be very okay, because the 10600K is just 6 cores. 6 very fast cores. 6 cores that can pull stupid amounts of power, but nowhere near... Like, the thing is, this is the 10 core, and I actually did... Oh, right, the phone's run out of battery. Man, I should have written down the notes somewhere. Actually, I wrote it down somewhere. I don't know where those notes are now. Good job, me. Anyway, like, I did some tests where I downcore this CPU and what, like, the highest power draw you could kind of cool was. And, like, basically for the 6 core, it ends up being like 225-ish watts of CPU power draw. For the 8 core configuration, you're looking at around sort of 280 to 300. And then, of course, the 10 core. The problem with the 10 core is, like, like, you can kind of do 400 going into the VRM. You can kind of do it. So, yeah, VRM considerations is like, if you want to run a 10900K, you want a VRM that doesn't overheat while outputting 250 to 300 amps, because you can actually pull that now. If you tried to do that on a 9900K, like, there's no way. Like, the funny thing is, a 9900K should still be, theoretically, should be capable of pulling around, well, 250 amps should be doable on a 9900K, but you're never going to hit that because it overheats. Whereas here, this doesn't. So that's kind of the ridiculous part of the 10900K. And actually, I'm pretty sure I was running 300 into this. So yeah, like, I don't know. Like, I'm just excited about the platform. I also realize that this video is just kind of going nowhere at this point. It's way too long. I feel like this should have been an article. Or more like, I should have better organized what I wanted to show in this video or talk about. But, like, I don't do launch day content, so screw it. There, I'm done with this. I'm not recording this again. I have stuff to test, like more ridiculous memory settings and yeah. Well, more like, I don't even have stuff to test. It's like I have to do a bunch of PCB breakdowns. So, and, like, I have videos to shoot, other videos. So, yeah, that's it for this video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with the channel, then, you know, I have a Patreon. You can support me directly through that. There's a link to that down in the description. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. There's a link to that down in the description below as well. Both of them help out immensely with running the channel, because, yeah, check them out. There. I've really screwed up the outro at this point, so I'll just hit the bloody stop button because this isn't going anywhere.